last but not least, we're going to use all this information to solve story problems. So story problems, also known as real life problems, we're going to have a 4-step approach to problem solving. And step 1 up here is understand the problem. Okay, when you read a story problem, you really want to read it, you want to underline things, you want to highlight things, and try to understand what is being asked, what is going on, what do I need to do. Then you're going to make a plan. How am I going to answer that question? What am I going to do to make this work? Once you have your plan, you're actually going to solve the problem. And then last but not least, you're going to look back and make sure, does my answer make sense? Okay, this is probably the biggest part in solving a real life problem. If you're trying to figure out how long it takes for someone to run a race and your answer is negative 5,008, it probably doesn't take someone negative 5,008 seconds to run a race because, first of all, time is not really negative. So always look back at your answer and ask yourself the question, does this make sense according to the story that I'm reading? Example 3, let's give this a try. So, in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Now, the first thing I'm focusing on here is it says I have to find his average speed. Well, average speed, in order to do that, is we're going to need a formula that we may or may not remember. And the formula I'm referring to, some teachers call it DIRT, but it looks like this: D equals RT. Now, what this is the D stands for distance, the R stands for rate, and the T stands for time. So we've got distance equals rate times time. When you stick two variables next to each other, that means multiplication. And for our purposes, if we're trying to find the average speed, that's your rate. So average speed. That is what we are trying to find. Also think about, like, in the car, if you're driving down the highway, you're probably going 60 miles per hour. That's your average speed. Or if you're like in town, you're probably going more like 30 miles per hour, and we could find your average speed. So it's your distance in relation to your time. So let's take this a step further. If I'm going to use this formula, I know that he ran a 200-meter dash. That is going to be the distance that he ran. And I also know that he ran it in 19.32 seconds. That is the time that he ran it in. So I'm going to substitute my values. I'm going to take my 200. I'm going to substitute it for the distance. So 200 equals the rate times the time. Now I'm trying to find the average speed. So we did the writing part. We wrote an equation. Now we have to solve the equation. So if I take a look at my equation, I'm trying to solve for R. This is 19.32 times R. Opposite of multiplication is division. So I'm going to divide by 19.32. I'm going to divide this by 19.32. I know that these are going to cancel one another and leave me with my average speed. Now I have to take 200 divided by 19.32. 200 divided by 19.32, which is going to give me 10.3519, something like that. 10.3519. Now, a couple things to consider. First of all, it's at average speed. Remember we had the conversation about speed in a car is like miles per hour? So if we just found his rate or his average speed, well, that's 10.3519 what? Like, what was it? So we're going to go back and we're going to say, okay, well, 200 was meters, and 19.32 was seconds. And we divided the meters by the seconds. So we're talking meters per second. Then the other thing we're going to consider is it says specifically that you have to round to the nearest hundredth of a meter per second. Oh, and look, it gave it to you there. Great. We could have just looked at the story problem. Hundredth. Hundredth is 2 decimal places. Tenths, hundredths. Underline it. Look back. 5 or above, give it a shove. 4 or below, let it go. So if I look at my 1, or if I look at my 19, it's below half. It's below 50. Okay, 1 is smaller than it's in the 4 or below category. So we're just gonna let 35 go, and we're gonna say 10.35 meters per second equals our rate, which was his average speed during this race. He was running pretty fast. If you guys remember a meter is roughly 3 feet. It's like a yardstick, and he's running about 10 of those per second. He's moving. Last one, number 4. You thought the balance in your checking account was $68. When your bank statement arrives, or in today's day and age, when you go check your bank statement online, you realize that you forgot to record a check. The bank statement lists your balance at $26. Write and solve an equation to find the amount of the check that you forgot to record. Okay, so let's think about this. You thought you had $68. You really only have 26. But somewhere in there was a check. Now, if you write a check, or in this case, you guys might not even know what a check is. You know, it's like it's your credit card or your debit card. So writing a check is like going to the store and swiping your card. Does that money go into your account, or does that money come out of your account? Well, when you swipe your credit card, that money goes out of your account because you just spent it on something. So the equation we're going to look at is we're going, okay, I had $68, but I spent money. I wrote a check, or I swiped my debit card. So that money is minus whatever that check was, or whatever the debit card was. So I had $68, but I spent some money that I forgot about. And really, I only have $26 in the bank account. So the question is, well, then how much was the check for? Like, how much did I go to the grocery store for, or how much did I buy on that pair of shoes, or whatever I bought? Had 68, spent some money, now I have 26. How much did I spend? That's your equation. Okay, so that's the right part. Now we have to do the solve part. And this one, actually, I'm going to solve it in 2 steps. So I really hope you remember some things from last year. First of all, I want to get my C by itself. So I want to get rid of the 68. This is a positive 68. So I'm going to do the opposite, and I'm going to subtract 68. 68 minus 68 is 0. Now, in this case, do you notice that that is not just C, it's a minus C. So when you bring it down, you have to bring minus C. Then we're going to take 26 minus 68. 68 is larger, which means my answer is going to be negative. And 28 minus 68 is negative 42. Now, we are trying to solve for C. I want to know how much money I spent. So in order to get just C, I need to get rid of this negative 1. So I'm going to divide both sides by a negative 1. The other option is multiply both sides by negative 1, but I'm going to divide. So this negative 1 will cancel this negative 1, and I will just get C. A negative divided by a negative is a positive, and negative 42 divided by negative 1 is positive 42, which tells me that the check that I wrote, or the thing that I bought, was $42. Okay, now let's see if that makes sense. I thought I had $68, but but I spent 42. So now my bank statement tells me that I have 26. Yeah, if you take 68 minus 42, you get 26. So whatever that check was or whatever I bought cost me $42.